Yeah, it was fantastic. I sat through a lot of different talks. I had absolutely an amazing time listening to the ideas and concepts. So I want to talk about something that we all deal with every single day. We go to work, and we go to work to deliver value. We go to work to create software, and we go there to have some fun too, right? But all of that is somewhat jeopardized when we have to deal with things that become extremely complex. Well, I'll start with first saying, when I was a child, I had the habit of saying really scary stories. I've grown up now. I just talk about programming. And that's scarier than anything else. And when it comes to software, I came to the field of developing software because of the math and science in it. But I stayed being a programmer for a good 3+ decades because the aspect of art in it just intrigues me. And it turns out that there is a combination of math, science, engineering, and art, and that's one of the things that excites us in terms of how we program in this field. But when it comes to software, though, we constantly hear these phrases. The one thing is, the only constant is change, as Heraclitus said. And we have to deal with the change all the time. It's change in requirements, change in the environment, change in the libraries, change in the team. Every single thing we can imagine around us keeps changing. And yet we are supposed to deliver the software as much as we can. We all talk about agile so much. Now, when I go to companies, they're very eager to tell me, oh, Venkat, we want you to know we are all agile. And I often tell them, I'm so glad we can get that out of the way. Now let's talk about what you actually do. And to me, the most important word I'm looking for is sustainability. If we cannot sustain the pace of development, there's no point in talking about agile development. So what does it really mean to be really agile? I'm going to say agility is about the ability to adapt to change. The most important word here is adapting. If you cannot adapt to change in your environment, in your project, in your requirements, in everything around you, then there's no point in really calling ourselves to be agile. And I'm going to say probably the most unpopular tweet I ever wrote, and I'm absolutely embarrassed for it, because I wrote it when I was actually having lunch, and I just immediately, spontaneously tweeted it. And this is the one tweet that probably got the maximum number of retweets of any tweets I've ever made, to the point I was actually absolutely embarrassed. And here's what my tweet actually said. It said, I've set the wedding date, I've not asked her out yet. This is how software projects are managed. If you really think about it, imagine this wonderful lady is sitting, and suddenly this guy shows up and says, sweetie, we're going to get married in June. We're going to have 3 children. Here's where we're going to live. Here are the names of the children. And she's like, who the heck are you? Well, I'm a software project manager, right? So this is how software projects are managed. And you go to work, and they tell you, we have set the deadline, we have set the scope, we have set everything. And I always say, what's there to be agile anymore? Right? There's absolutely no reason to even try to be agile when we are trying to be as deterministic as everything else is. And so one of the things to ask the question is, are we really adaptive? Are we able to change? Well, of course, there's a lot of stuff to talk about, but I'm going to focus on one thing, one aspect of what really makes it hard for us to make the change. And it turns out one of them is complexity. So when it comes to software, complexity makes it really hard to adapt to change. And even if you have the best of the teams, even if you have the desire to really make the change, you get just dragged in and get sucked in and get beaten down by complexity. And when you want to really make changes, it becomes enormously difficult. And so if we can really keep an eye on that complexity and reduce it, that can be really, really helpful. But I'm going to say there are 2 kinds of complexity we have to deal with. One is called the inherent complexity, and the other is called the accidental complexity. The inherent complexity comes from the domain, the problem domain itself. For example, let's not be naive about it. If you're dealing with an e-commerce software, if you're dealing with the banking industry, if you're dealing with the tax laws, if you're dealing with medicine, there is complexity associated with every single one of these domains. You cannot just wave a wand and say, I'm going to remove that complexity. No, you cannot. You have to deal with that complexity that comes from the domain, the inherent complexity. But unfortunately, a lot of what we deal with every single day is actually accidental complexity. So where does accidental complexity come from? Accidental complexity comes from the solution we use. And when you use a solution, it brings complexity. And to solve it, what do? You put some more solutions on top of it. And that brings more complexity. And to handle that, you put more solutions on top of it. And then you get dragged into this vicious cycle. And then it becomes really hard for us to get out of it. So if we can really look at a problem and say, this is inherent complexity, let's deal with it. Oh, this one is accidental complexity, let's remove it. I think we can do a better job at what we do. So complexity really makes it hard for us to adapt to change. But of course, system design is complicated. Let's not really ignore that. We are dealing with software for so many aspects of life and commerce that there is complexity that comes from it, but that's really complicated by nature. But unfortunately, we take what's complicated and we add complexity to what is already complicated. And this makes our lives really hard in the long run. So if we can deal with that inherent complexity and remove this accidental complexity, I think we can do really well. This talk really is about my journey through, I'm a consultant, I work with companies, and I work with clients, and when I go in, I try to understand what they are doing, and I'm trying to really help them. And these projects I'm going to talk about today are really things I've actually seen in the field. Every single one of them are things I've actually seen on real projects. And when I go in, if you ask me what do I do for a living these days, I'll say that I spend more time removing code than writing code. Because when I go to companies, I see that they are dragged themselves into complexity. These are very smart people, nice people, but they're so close to the problem they don't see it. And as an outsider, I'm not smarter than them at all, but I just don't have the context they do. And when I come in, I ask the silly question, like, why are you doing this? And then we start asking the question over and over and over, and then we realize they are tackling things they're not supposed to tackle, and we remove stuff they are doing rather than putting more stuff onto it. And that's what I'm going to talk about today, is just share with you some experience examples I've actually seen. So I'm going to talk about complexity here, of course, but I'm going to say we are the victims of our own complexity. Accidental complexity comes from the solution, and we bring those solutions, and so we are responsible. And part of the reason I want to really talk about that here is, we always hear complaints around us. We are quick to complain, oh, my company won't let me do this, my management won't let me do this. But here is one thing we, the technical people, can take ownership for. Because this complexity, these details are highly technical. If you and me, who understand the technology, cannot deal with it properly, there is absolutely no hope. So I'm really a fan of, at some point, saying, this is something we can own. This is something we can deal with. And I feel that this is something we can actually handle than trying to put the blame on somebody else. We can take responsibility for that. So what really makes software system complex? These observations come from my experience observing projects. Here's the first one. I'm going to say there are too many moving parts, and I'm sure we all have seen this. Too many moving parts. You go into a particular application, and you see these levels and levels and levels of abstraction. You cannot just hold that in your head. And this is only getting worse by the day. With microservices, this is going to just go through the roof now. You don't have an architecture that's easier to understand, easier to maintain. If the complexity of a microservice is essential for your project, that's great. But if it's not, that's an accidental complexity you've brought in, and that's going to only make things really worse. Here's a beautiful quote by Leslie Lamport. He said, a distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable. This is even more true in the world we live in. The minute you click that little button on your mobile phone to the time you get the response back, there are literally thousands and thousands of failure points. It's a miracle that even things work, actually, isn't it? And by the time all this request goes and served and comes back and gives you the response, so many failure points, and you have to gracefully handle that. And that only becomes more complex as time goes on. But this reminds me of an experience I had with a particular project I was working on for a client. This particular company came to prominence a decade or so ago, and they wanted to, I'll be a little vague about it, not to be too specific about them, but they came to business by creating software for a huge commercial market. And so to do this, to really become powerful in this market, they started delivering solutions that were very customized for their own clients. To the extent I remember looking at their code, and literally in the code you can see if customer 1, if customer 2, there were code very customized for customers. But that didn't work too well for them. And then they took it to the next level. And they had XML configuration files. And you can configure anything you want to. So they decided to configure everything. And there is nothing in the code anymore. It can be configured through XML. And I looked at this and said to them, how do you guys deploy this product? And they showed me a group of people and said, those are our deployment engineers. They worked for 4 months customizing the XML so the product can be deployed on a client site. And when they deploy it, it would look so different from one client versus another. And they did this for a while, but got to the point where they could not make progress anymore. Because for every client they signed up, or a variation of the product they signed up, they would need 6 months to really deliver the product. And this became unbearable. Excessive number of configurations. Everywhere you turn, there's something you can configure. Unnecessary components. The hierarchy is just unbelievable. You cannot understand where things start and where things end because it's so complex, and that's really hard to manage. And too many layers. As I looked through it, I realized what they have done is configuration in XML. And I came to a realization, configuration in XML is configuration from hell. And this is something you have to deal with. It becomes enormously complex because XML, I remember the time before, there was a time in history there was no XML. And when XML came about, people like me looked at it and said, oh, this looks cool, how wrong we were. And no human should ever be allowed to edit this without gloves. This is unbelievable. And yet we did, right? And yet we did, and we maintained it, and we kept on going with it. And then I finally realized, somebody asked me the other day, oh, how do you describe XML? Here's my definition of what XML is. XML is like human. They're very cute when they are small, annoying when they get bigger. And this is how I feel about XML. It is really horrible to maintain. It becomes hard to deal with it. And it's really tough to manage projects. And so as time goes on, we realize what appeared to be a really good idea in the past may not be such a great idea after all. Maybe we shouldn't go that far. So what can we do? What are some of the signs to deal with this? And a few things to really think about are, your application becomes really brittle. It becomes error-prone. It becomes hard to deploy. I always tell developers, if you find it hard to deploy during development, it's an early warning sign of what the cost is going to be later on. So we can start really getting a sense of it early on. And it's hard to reason, but here's something else to really think about. And one of the things to really think about is, when you talk to developers, we are very smart people, but sometimes we are also very too polite. And we use what are called euphemism. Euphemism is where you say a really bad thing in a nice way, right? And so you probably have heard developers say this. They say, this code is hard to test. Well, if you go to them and say, what are you really saying? What they're really saying is, the design of this code sucks. That's what they really mean. So rather than saying the design of this code sucks, we often say, oh, this code is really hard to test. But this is an early warning sign. I don't want code to be testable. I want the code to be tested. Because when you really think about it, if a code has a lot of moving parts in it, it's almost impossible to really stay sane while trying to automate and test it. So this is a sign for us to rethink about what we do, and maybe that's something we can take a note of and say, how can we make this testable? And that can actually lead towards maybe rethinking about what we're going to do in terms of how we are designing it. So too many moving parts is one thing. The next thing I'm actually angry about. And this one, I wanted to give a name for my anger. And I stepped back and said, what really bothered me? And I came up with this name, and that is, I call it as invisible changes. And here's the story behind this. A group called me and said, hey, we got this code written in C++, and we want you to implement it using a modern language, modern libraries, and stuff like that. I should have said no. But unfortunately, I said yes. But just for the sake of context, I'm not new to C++. I would say if there is one language I'm probably the most familiar with, I would say that's C++. I did most of my commercial development in C++ back in time. I was teaching C++ for about 12 years of my life. I've kept up with the recent changes in C++ language, 11, C++ 11, 14, 17. So I know the language really, really well, if I can even claim for this particular purpose. But then I started reading the code, and I started reading it. And to be fair, it was not a very long piece of code, only about 400 to 500 lines of code. And I read it again, and every line I read, I felt more stupid. And I was like, why am I not understanding this code? And I read it again, and I read it again, I couldn't figure it out. And finally, I got so frustrated, I sent an email to the team and I said, is there a research paper based on what the code is written? And they're like, oh, of course, here's the link for you. I'm like, thank you. I threw the code away, read the research paper, wrote the code, sent it to them and said, don't call me again. And I was so frustrated. But then I thought about, why was I so unhappy? Why was I so angry? And then I realized what actually happened. I was in the constructor. And when I get into, I was so desperate, I was debugging the code step by step. And I am in the constructor, the object is almost empty. It doesn't have anything. And I'm stepping through one line at a time. Then I step through one more line, and the object's like, pff. I'm like, whoa! And that method was called get something. I'm like, why would you get something and populate this? I'm like, okay, no problem. Restart the debugger. I come to that function, step in, and then step in. Now I'm 7, 8, 9 levels deep in this rabbit hole. I'm like, when is this going to end? How far is the end here? And I'm like, never mind. I'm not going to ever be able to figure this out. And it got me so angry because I felt cheated as a programmer. Because this is not what one programmer does to another programmer, right? You're like, come on, this person has to read it. Let's think about the person who's going to read this code. And then I realized that this is something that really bothers me. There are two kinds of code that frustrate me the most. The first one is the one that won't work. And I'm like, why doesn't this code work? The second is the one that shouldn't work but does. And this is driving me crazy, right? How many times have you looked at this and said, this is not supposed to work? And you're sitting there and asking, why does this damn code work? And this is very frustrating because this is a time sink. We're wasting time, we're wasting money on projects. When we have to deliver working software, we can't do it because, did you notice that? That's working, but it's not supposed to. And your team kind of gets together and say, yeah, and they're reasoning through it, and yet it defies all logic. And then when you find it, how do you feel at that point? You feel like you want to strangle somebody, right? Because he or she did this to me. And this is not what we want to do. We want to make the code absolutely transparent. You want to tell the developer, here's where you are, this is what's going to happen next. And I always tell this at my home, please don't surprise me. I got enough of that in the code already, right? And that is one of the things you want to really make the code visible, not an invisible change, because it becomes really, really hard to work with. So don't sneak around and make change to the state. Let's make it very obvious so the programmers can actually, be in line with you and they can walk with you. And like I said, this is a time sink. It becomes an economic nightmare, and we waste time and money on the projects. The next one I want to talk about here is uncontrolled mutability. Now, we all, programming in languages like Java, C#, C++, we do this all the time. We mutate stuff over and over and over. If you go to a programmer who does this and say, you shouldn't mutate, they're like, where are you from? So we actually do mutation. Mutation is okay. We do this. What about sharing? Sharing is a good thing. Remember what mom told us? You should share. So sharing is good. Mutability is okay. But shared mutability is devil's work. And the minute you bring shared mutability, everything goes haywire. But if you really think about it, this is called predictively irrational. I want you to just think about this for a minute. Step back in time for a minute. We have thread. Well, today, of course, we have executor service, which is pool of threads, but doesn't matter. To a thread or executor service, what do you pass to it? Oh, we pass a runnable. Great. Let's think about this for a minute. What does the runnable do? It starts a task on a separate thread. Your thread is here, that thread is running there. That's awesome. Let's think about runnable for a minute. What does it take? It has one method, void run. Just look at that for a minute. What does that method say? I will not take anything from you, and I won't give you anything back. How rude. There are some people that work like this, right? You can't talk to them, and they won't talk to you also. So what does Runnable say? Runnable says, if you want to use me, you got to put stuff over there, and I will come and get it. And then how do I get it back? I will mutate it, and you can get it back. Oh, excuse me, isn't shared mutable the root of all problems? Uh-huh. Now, where is logic here, right? So this was dead on arrival. And they kind of set us up and said, let's see when they figure this out, right? And this is just unbelievable. And we are trying to deal with this in terms of concurrency. How could that go really wrong? And then what do we do now? You start all these threads, you have all these mutable variables, and you are sitting there and like, let me think about it. This one is changing it here, that one is changing it here, this variable is changing it here, and you are trying to build all this in your head. How does it feel when you code like that? And so mutability needs company. It often hangs around with bugs, and it leads to, I'm going to say, state transition leads to brain damage. This is why we kind of look weird sometimes when we are programmers, right? And then what happens? You have built all this in your head. This is what programming is, isn't it? I love programming because you could be sitting or standing by the desk, and your hands are on the keyboard, but in your mind, you have built this absolute phenomenal model. And you know which object has which variable right now, and what other object has what other variable, and who is talking to whom. And you have all this in your head, and you're in this absolute moment of zen. When somebody opens the door and says, have you had lunch? And you just stare at them. What? And they're like, have you had lunch? And you're not responding. And they look at you and say, you're weird. And they go away. And you are absolutely irritated. Only programmers will understand this, right? You're absolutely irritated. And then, of course, at this moment, I'm going to see if I can connect the audio here. Let's see if that works. So at this moment, you were the person who, so at this moment, the person comes back and says, you're weird. And are you okay? You're like, no, because you have to put all this model back in your head. And 30 minutes later, you're about to reestablish all this connection in your mind. When the next person walks in and says, how are you doing? You're like, get out of here now. That's how you feel about it, isn't it? There could be two programmers working with each other, and we have this connected, shared model in our minds. And somebody comes in and opens the door, and that's it. We both are on the floor now, putting it back together. Now, this is one thing I've actually realized. The best money I ever paid in my life, hands down, was to the movie Social Network. I was watching this movie with my wife, and there was one scene. Right in the middle of the scene, in the theater, she literally screamed. She's like, oh my gosh, I get it. I'm like, whoa, what just happened? She's like, I understand you now. And I'm like, take my money now, take my money now. And I'll show you the scene where she said this, but this is a journey I love the most. My wife, absolutely a person I respect the most. Part of the reason is, she thought, decades ago, she thought she was marrying me. Then she realized, no, she married a programmer. And it took a journey. It was really a shock for her. But there was one day, we were recently married at the time, and she was about to go to shopping, and she said, I'm going to go to shopping. I said, sweetie, I'll be with you in 5 minutes if you want to wait. And she smiled and took the key and left. And I was pretty upset. And she comes back and I said, you know what, I said I'll be with you in 5 minutes. You just left, I'm really not that happy. And she came to me, put her hands on my shoulder and said, sweetie, I love you. I'm going to say this to you once, so you listen this carefully. She said, when you say 5 minutes, it's 7 hours in the real world. And that's when I realized, oh my gosh, she's right. Because what do you tell your boss? Hey, how's it going? I'm almost done. We have this absolute ridiculous perception of time. Because you would sit there and code. I'll be done in 10 minutes. 7 weeks later, still debugging, right? This is what our lives are. And I never realized it until she verbalized and said, that's your life. I'm like, wow, you nailed it. She's still with me. But here's the scene that I was talking about. So let's see if this comes through. Let me try this. So here we go.
I didn't know we had a doorbell. Andrew, get the door! No, he's wired in.
He's wired.
That's gonna cut into your security deposit. Andrew.
Not now.
Good boy. I'm Sean Parker. Oh, he's wired in. That's what I'm talking about.
That's what I'm talking about. Right at the scene, she's like, yes. I'm like, whoa. And she's like, I know why you're weird like this. You're not weird, you're wired. I'm like, this is amazing. A week goes by, I was working in the kitchen, looking at my computer and coding. One of my kids came and said, Dad, I have a question. My wife is like, don't talk to Dad right now, he's wired. I'm like, yes. And I came to a realization that happiness is when the world understands programmers. Because now you have reached that harmony. And this is one thing that is very important because we are not weird. We have to store all that stayed in our head. And we have to think intently. That's what we do. We're knowledge workers. And we stare at the ceiling, but we're not looking at the ceiling. And we are still thinking about how to make this algorithm work. And then eventually when it works, we get thrilled. And sometimes they say, you never believed this would work. Like, no, this is awesome. It actually works. And this is what we do. And so when it comes to this mutability and the state and all this transition is a cognitive load. And we have to deal with cognitive load every single day. So even if we can take a small step in reducing that cognitive load for ourselves, I think we're going to be better with it. The next thing here is lack of cohesion. So cohesion is, of course, when the code is small and focused. Cohesion is extremely important. We got to make it narrow. And so what can we do to make this? Why? Because we want to reduce the frequency of change. So one way to do this is to modularize the code. And whether that be a function or a class or a component or a subsystem or a microservice, as much as we can, we want to really focus on cohesion. Cohesion can modularize code, and such a modularization can reduce complexity for us. That can help us a great deal. Then comes along, of course, another thing we have to deal with, excessive dependencies. We have to deal with this every single day, isn't it? All those dependencies you have to deal with in your applications. And I was thinking about it. Over the past 35 years, what have I done? And I summarized this in this tweet. And I think this pretty much says the journey a lot of us went through. And I said, I've had one hell of a programming career. From DLL hell to jar hell through assembly hell down to NPM hell, what is next? I think I know what is next. It's called module hell in Java. But I'll tell you one thing, though. NPM is completely a different animal. NPM is awesome. Because the minute you start NPM, it'll download the internet with vengeance and then look for more. The other day, I was on the flight, and the captain said, folks, things are going really well. I'm turning off the seat belt, and you can move around if you wanted to. I shouldn't have done this, but I did. I opened my laptop. All I did was NPM install. Turbulence right away. And the seatbelt comes on, and the captain says, sit down. I'm like, sorry, didn't mean to do this. And I never run NPM anymore. I was at a client site, and they were they're on a Java project. And I know what the project is. You kind of scale it. Hey, you know what? This is a project. What should you be using? And a developer told me, oh, we used to run all these automated tests, but we stopped running them recently. I said, why did you stop running automated tests? Oh, because we upgraded some of the dependencies, and our automated test broke. I said, really? How many dependencies do you have? Without missing a beat, he said, oh, we got about 150 packages we are using. I'm like, 150? He's like, uh-huh. And he opens the dependency file and shows it proudly. And I'm like, wow, 150 for this project. Uh-huh. I said, why are you using 150? He said, because we found them. I love honest answers. This is what we do today, right? Going to lunch, you're having food with your colleagues. In the next table, somebody is talking about this XYZ package. And you look at your colleague and say, have you used XYZ? They're very sad. No. 30 minutes later, it's integrated. And this is what we do. How could we not have that package in our application, right? I was mentioning this the other day. And one developer said, oh, we don't have problems with dependencies. I'm like, really? Oh, yeah, we don't have to deal with that at all. I'm like, gosh, what language are you using? Oh, we use Java. I said, how do you not have to deal with this? He said, oh, easy, we use Maven. I had to deliver the bad news for him. Nobody uses Maven. Maven uses you. It's a dependency that comes through Maven and uses you. And there is no escape here. You have given up at that point, right? And this is really hard. We have to deal with this every single day. And that becomes really, really hard. And dependencies make our life absolutely miserable. And what can we do about it? Well, dependencies are hard to maintain. They become obsolete really quickly, and they become really incompatible over time. So if we can reduce dependencies, we can go a long way. For this, I want to talk about what I like to call as technology infatuation. This is a disease that a lot of programmers have. We are infatuated. The minute you see something shiny, oh my gosh, I've got to use it. No, don't get me wrong. I am a big fan of learning new things. I always do. I learn new languages, new frameworks, new tools. I'm eager to learn, thirsty to learn. But I will always put them to use on a side pet project. I want to keep learning on a pet project. So take the time to learn on a side project and have the wisdom not to bring it on board to your production code. Because we want to know if that is the right choice. And just because we saw something or heard about it in a conference doesn't mean we've got to go into production. We have to really take the time to learn, understand the pros and cons. I always ask my developers, tell me 3 things you like about it, 3 things that you don't like about it. If they cannot give me the balanced answer, they're being infatuated, right? They're like, oh, this is awesome. Like, but tell me what it solves. Tell me what doesn't solve really well. And why are we using this? That's very important for us to ask. So is this the right technology for you? Is it the technology for the right project? For the project at hand, we have to ask the question. And one question I will ask is reversibility. So what is reversibility? Reversibility is the ability to back out of design decisions, or any decisions for that matter. If I say I want to use this, and tomorrow I say, no, I don't want to, how easy or hard it is for me to reverse that decision out. If it's easy to reverse out, go for it. If it is really hard to reverse out, don't be so eager to commit to this because it can be really expensive later on. And we have to be very careful about it. In that regard, let's talk about libraries versus frameworks. Well, libraries, of course, you call a library, but what does a framework do? A framework grows around you. And I'm okay with libraries. I'm scared of frameworks. If you ask me what keeps me up in the night, it's the frameworks I'm using right now, not as much the libraries. But why is that? Well, the reason is you use a library, and it is easier to reverse out of a library. Well, in general, I would say it's easier to reverse out. The term I like to use is called surface area. If this is your library, and if you're using the library like this, that's a bad design. Because when I want to remove this library or change it, it's really hard because the surface area is really big. On the other hand, if I keep the surface area really small, and I have a little point of contact with the library, and tomorrow I decide not to use the library, I can take it away and put another one in, that's a lot easier change to make. With libraries, you can consciously you can make a design like that. With frameworks, forget about it. A framework has the biggest surface area around your code. It just grows around you and locks you in. It's very difficult to get out of it. So from that point of view, I would say using a library is like dating. Using a framework is like entering into a marriage. Don't take this too lightly. You could date and say, it didn't work out between us. Marriage, completely a different story. It's going to hurt really bad if we find this is not a good one. So we have to really take the time. It's not as reversible. So we have to really take the time to think about it and say, is this a right decision? So I always ask the question, what's your reversibility? If it's reversible, go for it. If it's not reversible, take more time before you commit to that particular decision. Well, I'm not going to tell you that the past was better than today. But I'll tell you it is different. And there are some side effects because of that. When I was young, there was no internet as we know it. This is always a good conversation to have with my children. They look at me and say, what do you mean there was no internet when you were a child? And then they will even more surprising. They say, you mean there was no Google? I'm like, no, there was no Google. And they kind of look at me and it's like, were you from the Stone Age? That's what they think, right? And there was no internet. And how do you then know about the products that you want to buy? You read about them in magazines. We had user groups, though. So we would go to user groups and somebody talks about it. And then we'd come back and we would do research about it. And through books and magazines and libraries. And then, of course, once you decide you want to use it, you make a request to your company. And that goes through a procurement process. And that takes a very long process to get through. And when it's done, eventually, one day, you will get this in the mail. It's a tape. And I was in charge of taking this tape to the tape drive and then spinning it on. When there is a tape drive between you and the software you want to use, you don't use softwares too easily. So we had minimalistic dependency back then. We evaluated. But today, we got one-click installation. Before you could blink, hey, it's done, it's installed, it's in production now. What is the next one we can look for? And we go out and bring things on board so quickly. And I'm not saying don't use an open source project. I'm not saying don't use things that can be downloaded. But we have to ask the question, is this the right choice? The other day I was talking to a developer. And he was saying, oh, we are using this. I told him, why are you using it? Because I know what your project is. I don't see any reason to use it. He leaned over to me and quietly said, do me a favor. Don't come and talk to my boss. We told him we cannot go any further without using it. This is called RDD, or resume-driven development, right? Because it looks good to put it on the resume. Awesome, we can. And that's what I always wonder. When I get a resume, I look for what's not in there. Because the list is just unbelievable. And then I ask them, if we hire you, will you use all of them on our product? And if they're like, happily, yeah, but no, sorry. We don't want to fail like you failed. We don't want to do that. But I'll share with you a very sad story. I call this the tale of infatuation. It's a sad story because this was a time when the economy was really bad in the US. I was working for a client, and we were desperately trying to hire people. And as we were interviewing people, most of them were really not good. But one person was amazing. So my boss came to me and said, hey, what do you think of this person? I said, don't waste your time. Hire him. He's amazing. I'm selfish. I want to work with him. I want to learn from him. Hire him. Oh, yeah, fine. What do you think of the framework he's been developing? Oh, it's the most amazing framework I've ever seen. It's awesome. Don't waste your time. Go hire him. Okay. What do you think of us using the framework? I said, oh, sit down. Let's talk about this. We got a 6 months deadline on our hand. We're working really hard. Please don't talk about using frameworks. Don't do that. Hire him. Bring him on board. Let's put him to work. After we finish the release, you talk about anything you want to talk about. It's a game. I'll work with you. But Venkat, that framework had persistent distributed transactions. I said, you never used those 3 words in a sentence until today. Why are you doing this? And then he said a few more things. I said, you never used that in a sentence. Please, I know where you're going. Don't do this. Hire him. Don't talk about framework. About a week or so goes by. I remember this clearly, Wednesday afternoon. I was sitting and working. He comes over, sits on my table, and says, hey, Venkat, I got news for you. Hey, what's up? Well, we hired him, and he accepted to join us. I leaned back in my chair and said, I can't tell you how happy I am. This is going to be awesome. We're going to rock. We're going to learn. We're going to do this. You know what? I'm just happy. Thanks for the news. Oh, by the way, as part of the hiring contract, we have agreed to use this framework. I said, oh, tell me you're joking. No, it's committed. I said, well, in that case, I just quit. He said, oh, I know you were going to say this. I already told my boss that you're going to quit when I tell you this. I said, I'm glad at least I'm predictable. So I put my stuff through. I said, hey, if you have any other projects, call me. But I don't want to be the bad guy on your project who keeps telling you this is wrong. Bye. This is one of the very rare days I actually show up to home on time. And my wife was like, hey, you're already here. Yeah, I quit. And she said, what does it mean you quit? Well, it means I don't have a job. And she said, well, in that case, I got some dishes in the kitchen for you to do. That's the way she is. And we rolled with the punch, and a few weeks later, I found something and moved on. 18 months later, I get the call. Hey, hello, this is Venkat. Hey, Venkat. Oh, hi. All right, go ahead and say it. I'm sorry? What do you mean? Go ahead and say it. Sorry, say what? Go ahead and say it. I told you so. I'm like, oh, no. What happened? Oh, we spent all this 18 months writing more code for the framework so we can use it. Hey, we didn't need the framework in the beginning. Why did we spend 18 months to improve the framework? Yeah, that's what we did. I said, I'm really sorry to hear this. What can I do for you? Well, I was wondering if you can come and help us. Like, no, there's a reason I quit. So no, don't call me, thank you. 2 years after I quit, 6 months after that phone call, my phone rings again. I said, hey, what's up? Well, I know you don't want to come and work with us, that's fine. I want you to come over, just look at what we have done, write a report, we'll pay you for the day, 1-day contract, we are done. Oh, you guys are done. Uh-huh. Well, okay, I'll be great, that's great. Here's the day, I'll come over there. So I go there at 8 in the morning. And I walk into the room, there's a computer there with a little instruction, and I enter this sample example that they had, click on the button. 25 seconds later, flip. I'm like, whoa, I time it, I profile it. And that one click resulted in a creation of 1,864 objects. I said, did you notice this? He said, it's object-oriented. I said, okay, database. Oh, don't even talk about it. This is faster than anything you'll find in production. Computer, don't talk about it. This is faster than everything. I said, wait. Where's everybody? He didn't answer. I said, no, tell me where's everybody? He said, they fired the entire team. I said, okay, now can you tell me why you called me here? He said, fix it. I'm like, oh, I'm a mortal human being. I'm not that smart. There's a reason I ran away. I can't deal with this. And that is heartbreaking. When you see an application that can be developed and released being driven in a direction due to technology infatuation. Don't build what you can download, but more important, don't download what you really do not need. And I always fight this in my projects. I want people to tell me why they are adding a dependency. They always talk about the cost they save by adding it. I always ask them, what's the cost to remove it? How expensive it is to get rid of it? And I want the economics of this before I make a decision on it and the reversibility. Otherwise, I'm not doing a good job. And I don't want technology infatuation on my project. I want to know I'm using things for the right reason, for the economic impact it's going to have. So from that point of view, I want to think about a few more things. Accidental complexity, I said. Low-level concurrency is an accidental complexity. Let's look at quickly one example here. So here is a piece of code that I'm going to start with. If you look at this code, there's a variable called Boolean done. And if you look over here within this, done is false to begin with. Then I come in here, you can see that it starts with a loop, and not done increments the count, and keeps on looking for done. And then 2 seconds later, I set the done to true. So here's this very simple code. Done is false, done is eventually true. This is looking for done to be different. Let's go ahead and run this code and see what's going to happen. When I run this code right here, you can see it started up, it's running. 2 seconds later, it says setting it's done to true, but it never, ever completes. What's going on? To make things really worse, let's play with this a little bit. I go to this code, and I do this absolutely silly thing. Catch exception, and within here, all I'm going to do is thread.sleep 0. Right? That's to add insult to injury. I like the way he laughed at it, right? This is amazing. I love it. Can you come with me? This is awesome to have that kind of laughter. Very nefarious laughter, like, okay, that's awesome. And when you run this, it finishes the code. Like, why? This is the beauty of this. Nobody who doesn't know what Java memory model should ever do concurrent programming. There was a time when I had not read about the Java concurrency in practice book, the best book ever written in the Java world, right, by Brian Getz. Before I read the book, I used to think, no one can get concurrency right. After reading the book, I know nobody can get concurrency right. It is that complex. And if you think about it, this is the way I look at it. There are 7 things in Java that cross the memory model: volatile, sleep, join, wait, and so on. Why 7 things? Imagine when Harry Potter came out. They gave you a list of Horcruxes, where they are present, where to look for them, and how they would look. Would you have been interested in Harry Potter? No. Harry Potter is awesome because you didn't even know they were Horcruxes. And then you had to go look for them. And Harry had to say, I don't have a clue where it is, I don't know how it looks, but go find it. Those are the Horcruxes. They planted for us. And they sat there and said, let's see what's going to happen. And we've been coding this for so many years, discovering these horcruxes that are going to cross the memory barrier, enormously complex. To the point I'm going to argue that how many of you program in assembly language? A few of us. I thank everyone who raised their hand. I thank you for doing that. You are doing it so the rest of us don't have to. This is how concurrency should be, in my opinion. Concurrency is the Java JDK concurrency is the assembly language of concurrent programming. Those hands are the few ones who should be doing it, and we should just pay them hefty to keep doing that so the rest of us don't have to. It's really horrible, very difficult, and for us to maintain it is incredibly difficult. So a key design skill we need to develop is the ability to discern accidental complexity from inherent complexity. And this is a service we'll provide for our own team by able to distinguish one from the other. And another one is imperative style of programming. I talked about this morning, so I won't repeat that here. Imperative style is packed with accidental complexity, and declarative can help us reduce that complexity a lot. But the last thing I want to talk about here is called entwinement. What is entwinement? Entwinement is where we take two things that don't belong to each other. They should never be near each other, and we bring them together. I was reading the other day, somebody decided to smoke. Fair enough. They had a big, huge can of gasoline. No problem. But they decided to smoke next to it. Not a good idea. And you don't want to bring these two things that don't belong together. And even the best of us can make this mistake. As an example, in Java, we have a class called resource. It has an external resource, memory outside, resource outside. It could be a file, could be a WebSocket, could be a service that it's open connection to, whatever it is that it's talking to. But I want to release it. How do I release it? Well, in the initial days of Java, which lasted for 20 years, they decided to create this method called finalize. When is finalize called? When the garbage collection kicks in. When does the garbage collection kick in? Maybe never. Not when you want it. Sometime in the future. It's completely non-deterministic. You took memory management code and tied it to resource management code. What is that called? Bad idea. So much so, in Java 9, they finally said, all right, that's enough. And they deprecated finalize in Java 9. I cannot be happier because they finally said, that's silly, don't do it. What is that called? That's entwinement, where you take two things, a resource management and memory, and put them together. And we took what should be deterministic and bundled it to what is non-deterministic. It doesn't make sense. It didn't work. Finally, Java 7 started a solution. Java 9 eventually said, let's get rid of the old one. In fact, this problem is so common that Rich Hickey coined a term for it. He called it complecting. Rich Hickey is the author of Closure, and he calls this complecting. Complecting is entwinement, but it's a term he made up. He called it complecting. So what is complecting? Complecting things is a source of complexity, he said. When you bring things together that shouldn't belong together, we deal with complexity that becomes hard to maintain. So we talked about a number of things here. We talked about too many moving parts, invisible changes, uncontrolled mutability, lack of cohesion, excessive dependencies, technology infatuation, low level of concurrency, which is an accidental complexity, imperative style, and entwinement. We should learn to deal with complexity and have the wisdom to minimize it. Because as technical people, the decisions we make today have a ramification for a long time. I was working with a client the other day, and I tweeted, and my tweet simply said, technical debt is the gift we give the developers who come later on. And that is something we always need to think about, right? It's not what we do today. How is it going to affect the people who come later on? We have to think about them. That becomes very critical. So we should really think about how to really minimize the dependency and have the wisdom to really do that. And I'm going to say a maintainable code is a gift we give ourselves for the future. And we should really work towards creating that one. Hope that was useful. Thank you.